All right, we're back again with part 5 of the 2013 release STAAR Geometry test answers. Going to be doing questions 41 through 50. So here it says, within a square section of land, a landscaper will build a path as represented by the shaded region in the section in the diagram below. Which measure is closest to the value of y? Okay, so real easily, if we could figure out the entire side, what those are supposed to be, and then this piece here. So let's call this x, and let's call this z, just to give it a name. If you could figure out z, subtract x, you'll be left with y. It would be an easy way to approach this problem. Conveniently, we do have some triangle pieces labeled there. Which means if I could solve for one side of the triangle, that will also be z. All of the side, because it's a square, all of them will be represented by z. And then we could use that over here and also figure out x to solve this one. So conveniently, this is a 30, 60, 90 triangle. The easiest way to approach this one would be to use special right triangles. So we know the hypotenuse is 15 feet. If I was to label this in terms of the sides of a special right triangle for x, I know the side opposite of 30 is x, opposite of 60 is x square root of 3, and the hypotenuse is 2x. So if I solve for x, I get x equals 7.5. So I get 7.5, and this is 7.5 root 3. All right, so then z, this side up here, is this piece here, is 7.5 root 3, and this piece is 7.5 square root of 3, and x we solved for was just 7.5. Okay, so that means that I just need to take this value and subtract this, and I'll be left with y. So 7.5 root 3 minus 7.5, so 7.5 times the square root of 3 minus 7.5. And we get about 5.49 or about 5.5 as our answer. So this value should be about 5.5. For 42, it says the top of a bench has a length of 5 feet and a width of 2. So top of a bench has a length of 5 feet and a width of 2. A second bench is similar to the first bench. The top of the second bench is 3 feet. So length of 5, width of 2. This one has a width of 3, so it's actually going to be bigger. Okay. So then what is the length of the top of the second bench? So we're looking for the length of the top of this one. Okay, this seems pretty straightforward. Ratio of corresponding sides. We can set up a proportion. I see I want to solve for x. That corresponds to 5. So a ratio of corresponding sides on similar figures. X corresponds to 5, and 3 corresponds to 2. So I'll multiply both sides by 5. And we get 7.5 on that one. Okay, moving on to 43. So here it says we have two triangles shown in the diagrams below. Based on the information provided in the diagram, what is measure of angle P in degrees? So looks like I have two congruent triangles based on side, side, side congruency, side, side, side congruency. I do know that I can tell which angles correspond based on those side markings. So in between 1 and 3 tick marks is 60 degrees. So in between 1 and 3 tick marks, this should be 60 degrees. In between 2 and 3 tick marks is 50. So in between 2 and 3 is 50. And that is our answer, because what is the measure of angle P in degrees should be 50. That is the angle in between the side with 2 and 3 tick marks on these congruent triangles. So 2 and 3 tick marks should be 50. So 50 degrees should be our answer of that one. All right, number 44. A civil engineer is drawing a plan for the location and length of a new underground sewer pipe. On a coordinate grid, the pipe on the plan will run from N to P, On the coordinate grid, which expression represents the shortest distance between N and P? So normally we just use the distance formula here and plug in the pieces, except for we don't know the value of A or B. So we're still going to try it. The distance formula says all you have to do is take the difference in x value squared, or x2 minus x1 squared, plus y2 minus y1 squared. And it doesn't tell us which one will be point 1 and 2, so let's just assume this is the first point and this is the second point. So that means this would be x1, y1, the x and y value from the first point, and x2, y2. So let's plug in the pieces then. Square root of x2 minus x1 would be 1 minus a squared. y2 minus y1 will be b minus negative 2. So b minus a negative, same thing as plus a positive. Should be this value here. And I look and see that does look to be one of the answers there. So this will represent the distance between those 2 points, N and P. So 1 minus a squared, b plus 2 squared. Yep, looks correct. 445 says the spinner modeled below, sector 1 has twice the area of sector 3. So whatever this is twice as much for that area. If the arrow is spun once, what is the probability that the arrow will land in sector 1? Okay, so I see between these two right here, they're both labeled 90 degrees. So that's 180 degrees of the circle, which means that there's 180 degrees left between the other two, because these two are 90. Whatever's left has to add up to 360. So 180 minus 90 minus 90, 180 left. So I know that degree-wise, let's look at this in terms of degrees instead. So let's call this x degrees and call this 2x degrees. I know that x plus 2x has to equal 180, 3x equals 180, and x equals 60. So this would be 60 out of the 360 degrees, and this would be 120 out of the 360 degrees. Okay, if the arrow is spun once, what is the probability the arrow will land in sector 1? Well, that's 120 out of the 360 degrees. So geometric probability says that we can use the degree measurements, we can use the area measurements to figure out the probability of something happening. So this simplifies to 1/3. So it should be 1/3 chance. All right. Question 46. A triangle is enlarged by multiplying each of its dimensions by 4. Based on this information, which of the statements is true? So you take a triangle, doesn't really matter. I'm going to just draw an easy one, like a 3, 4, 5 right triangle. And we take all the dimensions and we multiply them by 4. So 4 is 12, 16, and 20. Let's look at the statement and see which one is true. The perimeter of the new triangle is 12 times the perimeter of the original triangle. No, the original perimeter we get 12. This is not 144, so it's not 12 times as much. I think we get, what is that? 36 plus 12 is 48. So it's not 12 times as much. The perimeter of the new triangle is 16 times as much. Nope, definitely not true. Perimeter of the new triangle 18 times. Nope. Perimeter of the new triangle is 4 times as much. Yes, 12 times 4 is 48. So the perimeter of the new triangle is 4 times as much. Right. 47. The slopes of the sides of a quadrilateral ABCD are shown in the table. So we have a quadrilateral with some slopes given here. Which statement describes the relationship between the sides of the quadrilateral? Okay, so we notice we have some stuff here about these sides being parallel. We just need to remember that parallel lines have the exact same slope. And so when I have a quadrilateral here, it could be, you know, like maybe a trapezoid or a parallelogram. If some pieces are parallel, these pieces are opposite and these pieces are opposite. So let's look at these. Do these two have the same slope? Yes, which means they are parallel to each other. Do these two have the same slope? No, -2/5 is not the same thing. So these two are parallel. AB is parallel to CD because they have the same slope, positive 2/5. These two are not parallel. So BC not parallel to AD. And I think that's what our answer choices tell us here. Is AD parallel to BC? No, that's not true. Is AB parallel to CD? Yeah. And AD is not parallel to BC. That part looks like it's true. Just to keep on checking to make sure, AB and CD are parallel, and these two are parallel. No, that part's not true. First part was. AD is not parallel to BC, and AB is not parallel to CD. No, that part right there. This is parallel, so I know that part's not true. These two were not parallel, so that part is true, but this part's not true. The only one that had both true parts was answer choice B on there. Right, 48. Two motorcycles start at the same time. One motorcycle travels 15 kilometers due north. So let's say northeast, southwest. Let's say up is north, so it goes 15 kilometers. And stops. The second motorcycle travels 32 kilometers due west and stops. So the second one goes 32 due west. Which value is closest to the distance between the motorcycles when they stop? So the distance between these is conveniently north and west make a right angle. So we just have to do some Pythagorean theorem. So the two legs will be A and B, so 15 and 32. And C will represent the distance between them. So let's check and see what that is. Square root of 15 squared plus 32 squared. Looks like we get about 35.34. So 35.34 looks like answer choice H, which is the value closest between the motorcycles when they stop. Looks straightforward for that one. 49. A town wants to fence in a rectangular section of park. The table shows 5 possible plans for the dimensions of the fence section. The changes in the width and length of these plans follow a pattern. If 6 additional plans are added to the table and follow the same pattern, which conclusion is not correct? So, all right, let's see what's happening here with the width, the length, and the area. So the width looks like it's increasing by 2 every time. So every time we just add 2. The length looks like it's decreasing by 2 every time. And the area here, what's it doing? It's going up, 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 up. Is it a constant amount? Which conclusion is not correct? Okay, so this one's an interesting one. Let's go ahead and get a table just to be extra sure. So I'm going to label these as the plan, the width, the length, and the area here. So the plan, let's and the area is just length times width. 26 times 24 is actually already given to us. So 624. Same thing for the next one, 28 and 22. That was already given for us here. And we get 616. And 36 and 14, we get 504. So now that we have the rest of the list done, let's check and see if any of these are not true. The area of one of the additional plans exceeds 624. Nope, none of these plans exceed 624. So I'm pretty sure this is already the one that's not true. Let's just check and make sure the other ones are true. The area of one of the additional plans is less than 544. Yeah, the 11th plan, the area is less than 544. The area in plan 6 is the same as 5. 624 for plan 6. For plan 5, 624, that was the same. And the area for plan 7 is less than the area for plan 6. That's true. 616 for plan 7 is less than the area for plan 6. So these two were true. A is the one that was not true. Moving on to question 50. says the points A, B, C, D are the vertices of a square. Points E and F are the centers of two congruent semicircles that are tangent to each other at point G. Which value is closest to the area of the shaded region? So, okay, this one seems like a composite area. We just need to have a plan to figure out how to find that area. So I know if I found the area of a square, that would be this whole region here, and I would need to subtract off half of a circle and half of a circle, and I'd be left with just the shaded region on there. So if I started with the entire square, and then I subtracted off the semicircle, I'd be left with the two shaded regions there. Okay, so area is going to equal the area of a square minus 1/2 of a circle minus 1/2 of a circle. Since that's the same diameter or same radius, we actually get the area is equal to the square minus 1 full circle, because 2/2 of a circle make 1 full circle. So the area is going to equal base times height of the square minus pi r squared, area of a circle. So plug in the pieces. The base looks like it goes from 4 to 2 is 6. The height, since it's a square, is also 6. And the radius goes 3 units, so pi 3 squared. So let's plug that in our calculator. 6 times 6. Oh, that's not an equal. It's supposed to be a minus right there. Minus pi 3 squared. And we get about 7.725, and the instructions specifically ask us, 7.72. I thought this was we needed to write in the value, not have answer choices, so 7.7 is the closest one on there to the shaded region. Okay, I lied. We're just going to continue and go on through here. All right, the diagram below represents the layout of a hexagonal swimming pool that contains a drain at point D in the center of the rectangular yard. Other layouts are also being considered. Which layout is a result of a 90 degrees counterclockwise rotation of the original layout of D? The way that the hands on a clock go is clockwise, the other direction is considered counterclockwise. So I need to do 90 degrees or 1/4 of a rotation counterclockwise. So this shape, all of these points are going to go 90 degrees this way. So basically, if I was to take this shape and rotate it 90 degrees counterclockwise, I should only be rotating the hexagon, I shouldn't be rotating the rectangle, but it should end up looking like this. There we go. So we want one that ends up looking like this. So it looks like answer choice D. Does that look the same? Yep. So D. Remember, we're just looking at the hexagon, not the rectangle. So the hexagon does look the same for answer choice D. One more question here. 52 says we have triangle DAC shown, so the big triangle DAC, where segment EB is parallel to DC. So we can mark these as parallel. Great. We can probably use something like the triangle proportionality theorem or similar triangle. If AC is 28.5, so the entire distance from A to C is 28.5, then what is the length of AB? So just this piece right here. So given the entire side of a small triangle, we're looking for the entire side of the small triangle AB, and we know the entire side of a similar triangle. This is going to be a pretty easy triangle proportionality theorem problem. The reason I know they're similar is whenever you have a side parallel to a side in overlapping triangles like this, we know these are similar by angle-angle similarity. They share this angle up here, and because of the parallel lines cut by the transversal, they have congruent corresponding angles. So each of these triangles has angle-angle similarity. So I can use similar figures, proportions, to solve this. So I know on the smaller triangle, x corresponds to 28.5. And on the other side over here, I know 18 is a side of the small triangle, and that corresponds to the entire big side, which I would need to add those two pieces together to get 18 plus 4.8 is 22.5. 28.8. So 22.8. So then all I would need to do is multiply both sides by 28.5, and I get x equals 18 over 22.8 times 28.5. So plug that in the calculator and let's see what we get. 8 times 28.5, and we get 22.5 as our answer. So I'll go back and check. 22.5 is an answer choice. That is, this piece X we were solving for does represent AB, so yeah, 22.5 on that one. Another way you could have done this was using the triangle proportionality theorem and compared these pieces, but we didn't know this one. So it would have been a little bit harder to do by representing that piece as like 28.5 minus X or something. It would have been a little bit more challenging to do it that way. Using the entire sides of similar figures did make it a little bit easier. All right. Hope this helped. There are other test reviews available. I know at least one already posted has the video review answers. So please, if you're not feeling overwhelmed yet, go check out another one before you get burned out.